right. Welcome, everybody. Thank you so much for being here. My name is Hussein Shell. I'm a chief technologist, head of subsurface transformation at AWS Energy. And I'm here to talk to you about what we're doing with Eni. I'm very excited about the talk today. We're here with a very distinguished speaker from Eni, who with a wealth of information and experience around energy transformation. Apologies if the lights are too hard to look everyone in the face, but I'm pretty much excited to be here. First, I want to really give you a little bit of run through the agenda. We're going to talk a little bit about the changing landscape of energy at the moment. And then we'll invite Francesca to the stage to talk about Eni, what we're doing around geoscience, the project that we're taking on together, and the challenges that we're hoping to solve with this. And then I'll go through a little bit of the architecture, a deep dive into the specific services that we've used to make this possible. And then we'll finish with what our aspirations are and what the next step and the next phase of this collaboration. And with that, I just wanted to start a little bit to give you a bit of context on some of the work that we're doing and how it impacts the work that Eni in general is positioning. And so the modern energy landscape is really undergoing in its own a very profound and rapid transformation where the importance of energy security and reliability coupled with accessibility and affordability is really important to drive digital transformation and to look at technology as an enabler to do so. Coupling that as well with the urgency around sustainability and energy transition and the challenges that bring up, it really created a critical demand for looking at clean energy sources, propelling organizations like Eni to deal with the challenge of keeping economic considerations with environmental responsibility. And so this intricate balancing act that requires companies to innovate swiftly and leverage technologies to the fullest, and strategic partnerships really that we haven't seen before, whether it's with cloud platforms or solution providers, to meet the demands of a future where the trifecta of secure, reliable, and sustainable energy is no longer just a choice, really, but an imperative for both corporate success, but also global well-being. And so that is driving a significant amount of digital transformation. And many of our customers, energy customers in particular, you've heard a lot about the transformation work that's happening with other industries as well, but particularly in energy, we're working closely with customers like Eni and partners to really drive lower emissions type of workloads, lower costs, improve production, and help increase and really minimizing risks in certain workflows that we're targeting. And so the integration of advanced technologies, whether it's machine learning, generative AI, high-performance computing, IoT, is signaling a significant stride towards a sustainable energy solutions driven by technology and advancements. And so with us today, as I mentioned, Eni, an Italian multinational company, really pioneering global exploration and production in very challenging environments, but also are recognized and considered as a pioneer in diversifying their new energy solutions and energy transitions portfolio around solar and wind, et cetera. So without further ado, I'd like to welcome Francesca Salvi, who's our guest speaker, head of geological and geophysical studies at Eni, to talk about what we're doing together. And so please give her a warm welcome.
Thank you, Hussein. Thank you for this warm introduction, and above all, thank you for this opportunity. It's really a real pleasure to be here. As anticipated, my name is Francesca Salvi. I'm working in Eni as head of geological and geophysical studies in natural resources direction, and I'm a geologist as background. So Eni is an integrated global energy company which activities are covering the entire value chain, starting from the exploration and development of the geo-resources, where I'm more involved, up to the final product and services of the chain. We are working in 62 countries worldwide, involving more than 30,000 employees. And this attitude to work abroad, bringing long-lasting relationship with the countries where we are operating, came from our founder, Enrico Mattei, since the 50s, driven also to the needs to explore and discover new geo-resources for our country, Italy. And the same vision of our founder, based on the people, technology, and sustainability, is the vision, is the mission that we have now nowadays. Here, fully reported, highlighting the links between our mission and few of the Sustainable Development Goals. So Eni is targeting the carbon neutrality by 2050, and we are fully committed in the energy transition that is socially fair, preserves the environment, and provides energy everyone who needs it. And these three main pillars are the same that Hussein have already mentioned in the previous slides, and are the pillars of the so-called energy trilemma, for which the energy has to be, first of all, sustainable, secure, and affordable. But the question is now, which roles can have the geosciences in this so challenging and complex framework? Here we reported a sentence from the commemoration event for the 50th anniversary of the International Geoscience Program of UNESCO held last year in October, saying that in the wrestling with the scientific limitations in studying an ever-changing and dynamic planet, limitations such as incomplete data, lack of experimental control, and the inability often to take direct measurement, the geoscientists have the potential to apply the unique scientific skill set and mindset to tackle the similar uncertain challenges faced by the sustainability science. And such holistic understanding is crucial to the successful implementation of the Sustainable Development Goals. And so the geoscientists are here defined as the core of the humanity's mission to secure the sustainable future. It's quite powerful, of course, if you are a geologist, but it's quite insightful also because in few words it summarizes the peculiar attitude of geosciences to face to the uncertainties of the Earth systems. So, but let's get to the point. Nowadays, with the current technologies, we can acquire a full quantity of data. And through this data, we can apply also the same holistic approach that we have seen before in order to define and identify the more cleaner mix in order to support the energy transition. And in this challenge, the geoscientists can play a crucial role in identifying and de-risking the site of interest in the subsurface to store energy like hydrogen or natural gas, but also to store the CO2 in order to reduce the global emissions, and again to characterize, for example, geothermal energy, and for example, identify the shallow aquifer for the fresh water for the humanity. And again, now let's get to the point in order to see how can we approach this challenge. As I was saying, nowadays, the current technologies and the computing capabilities allow us to acquire a huge quantity of data, to repeat the measurement over the time up to a real-time monitoring of the evolution of the surface, and sometimes also of some parameters in the subsurface. So following this path of observing, learning, exploring from the data and experience, we can obtain a global vision of the Earth system, a unique perspective that is the real challenge of the future. But here, a question arises. So can the geological workflows be digital? Here we reported on the left a seismic section on the subsurface that belongs of the geophysical domain that is typical digital native. On the right, a typical environment of the geologists, an outcrop, a beautiful outcrop indeed. So I don't know how many geologists are here present, but in your opinion, which is the preferred tool of the geologists to perform their job? What do they love most? Something that is tangible, feasible in 3 dimensions, measurable, something such as the rocks. And sometimes in the early years of the university, the teacher even asks you to taste and lick the rocks in order to feel the flavor, the compositions, the grains. That is quite rude but effective. And so how can we combine and emphasize and exploit this attitude of the geologists and geoscientists in a modern, environmental, and innovative world? So indeed, if we go a little bit more deeper in understanding what are the geological workflows and data, we have to highlight how much heterogeneous they are. The workflows, indeed, if we think that they have to cover a wide range of scales in terms of time, geological era, and space, from the microscope to the crustal scales, for example. And the workflow, the geological workflow, is a very analog workflow. Since we have to understand an active geological system, for example, a fluvial system, in order to understand what is invisible, buried in the subsurface, that is fossil in the past, no more active. So we have to understand the present in order to reconstruct the past. And moreover, the workflow is built on a broad and different, as we have seen, data that has to be connected by an even broader metadata fabric that connects the data to the people to the application in order to lead to the right decision. And again, focusing on the data, they are different, heterogeneous, as we have said, and this means that we have to face a tangible resolution problems in order to identify also the right tool in order to correctly observe and understand from the data. And this heterogeneous means also that the geological workflow is not possible to standardize easily the geological workflow. And so an ad hoc workflow is not an exception in our way of working. And finally, again, related to the data, nowadays is more and more necessary to have the full data consistency because we are requested to accelerate the development of our project. So you have to guarantee a full data consistency between the data that are used by the different functions. So in a so peculiar and complex framework, and considering all the aspects that we have seen so far, the geological workflow seems to be the ideal candidate for a digital innovation, since we could improve our efficiency, and we could also strengthen our way of working, giving more space to the creativity that it is one of the key factors of our job. So today, indeed, the same space is made by different and disjointed tools developed by external providers or internal experts, and this could lead to the limitation of the intuition innovations, and also could occur a lock-in situation. And, but on the other hand, the same space should be the space where the people, different expertise and specialists connect themselves and give space to the brainstorming, the sharing knowledge, and the connection. And this is, again, one of the main reasons of our success in the exploration activities during the last decades, for example, saying in the North Africa or in Zohr in Egypt. So the digital transformation can improve our process. We can evolve while maintaining this skill set and attitude. And the building of a geological collaborative ecosystem could improve our approach. This ecosystem should have should be highly connected metadata platform, leveraging open data and proprietary also data model. Eni has quite good experience in building a specific domain data platform, and this knowledge could be a milestone. It is a milestone in this vision that we are describing. So the platform also will include some 3D imaging technologies for the visualization of all the data and also to improve the cross-domain collaborations. And also, of course, it will leverage by the technical capability of machine learning, artificial intelligence, and in order to capture the domain knowledge and automate the workflow where possible. So in other words, we should build a playground to unleash the creativity of the geoscientists. So, in other words, again, what is GECO? GECO is a collaborative platform for geoscientists to support a sustainable use of the natural resources and to de-risk any kind of geohazard. The range of the range of the applications is quite wide, starting from the exploration, exploitation, development of the georesources up to the development of renewable energy, without excluding also some application outside the energy industry, such as the educational and training applications. GECO will make available, searchable, and accessible all the structured and unstructured data within the company, and not only, in order to minimize the uncertainties for the reconstruction of the geo-modeling of the subsurface. The ecosystem will be, of course, open and extendable, supporting the data integration for multiple content providers, with extensible data model to support new inputs and domain. Of course, if we say evolving while maintaining our capabilities, our attitude that we have described before, that means also that we have to place the humans at the center of the technology, at the center of the platform. In this view, the platform will make available the information based on the user profile and or the type of job that the user has to perform, and drawing from different type of data, documents or tables, or different type of sources. That can be proprietary reports, scientific literature, and technical papers and documents that we perform internal the industry. In this way, the geoscientists will be able to view the data, or depending their geographical distribution, geological domain, and also preferring to visualize one source respect of the other. The infrastructure is designed in such way that the creativity, the intuition of the users are maintained and stimulated, also highlighting information that they would not have selected following a consolidated and traditional process. It's quite common that people with a high level of knowledge, a scientific knowledge, the tendency is to look something that you already know, or to go to the so-called comfort zone, or to obtain some information that you are already foreseen. But in this case, the target and the aim of the ecosystem is also to highlight something that is unknown, to challenge the assumptions of the user, and to highlight the outlier in order to support and stimulate the creation and the innovation. So the platform, it will be also the technical solution that will improve all the activity of our company, Eni, at global scale, worldwide, but also it will be also the desired solution for sharing geosciences data between the stakeholders in a safe and secure environment, thanks also to the capability of AWS and supports. And the platform will consider international standards in order to be open and extensible. And the synergies and the collaboration between Eni and AWS has provided an excellent opportunity for growth and an excellent example of complementarity and synergy on different aspects, such as, for example, as we have said, the capability to work worldwide at global scale. And again, also, from one side, Eni, the experience and the knowledge in geosciences domain, plus the experience in the creation of collaborative data management systems, with the capability of AWS and the guarantee that came from AWS of multi-level grant administration and security, so a safe space. And also, of course, sharing the mutual experience in innovative technologies involving artificial intelligence and natural language programs. But now let's see some preliminary captures of the module that we are developing of GECO, focusing on unstructured data. These we can see the landing page, for example, from which the users can start to dive and interrogate the systems based on a customized profile and querying some natural language questions, for example. Right now, the system supports two types of data sources, documents and proprietary databases containing geological information in specific domain. Following the natural language questions, in this case, in this example, we see a natural language question focused on a quantitative data, for example, which is the porosity of defined rocks. The page of results is populated, proposing the relevant paragraphs from the internal document. In this case, this is the reason that some words are grayed. In yellow, you can see highlighted the keywords included in the questions. And on the left, you can also, as user, select and prefer the type of data that are visualized and also make other preference in the searching mode. And another way in which the system, by leveraging the generative AI, can support the research and the study of the geoscientists is a proposed summary, recapping and the main, in this case, values of the porosity that I'm looking for, with the minimum and maximum values that are reported in the available documents. Each document is related with the document metadata, so there is always the possibility to check the sources of the information that are reported. And each document is also related to the so-called business entity or business object annotations that depends, could be wells, formations, basins, and so on. Again, another example that highlighted the capability of the system to propose you even more longer summaries, depending on the question that we are asking. In that case, again, a natural language question, quantitative, focusing on the quantitative values. In this case, the system was able to split in 3 items the question and so the answer. But the user, again, if is not satisfied of the summary or the answer, can re-ask a new generation of summary, changing, for example, some input. And since we have seen the geographical location, of course, is an important factor in our job, the system is also able to propose the documents, the relevant documents answering to the questions, again, natural language question, with the proper geolocation. Since if in the document is reported, was included at least one geographical information, all the objects are geolocated. So proposing paragraph, relevant paragraph, but even images if needed. And another example, just to highlight that the system is able not only to answer natural language questions focused on the quantitative, but also on the qualitative information. For example, in this case, the question was related to the main orientation of some geological features. And so again, the system proposes you some of documents that are reporting this information in that specific geolocation with a summary of the main trend and the main information included in the available documents. The answer are also, it is possible also to have some answer through the images instead of the text. Indeed, following a natural language questions, the system can propose you some of images that are classified within the documents between seismic, for example, that is one of object of interest for us, maps, geological maps, or plot. And again, in that case, the system is able, also in this case, to propose you a summary of the main information included in the images and from the captures. We decided also to integrate the system with 2 tools, additional tools, able also to extract some quantitative information from the plots. For example, in this case, that is a plot digitizer. Thanks to this tool, the user can focus on a specific plot, and after a very, very quick setup of the axis, extract the value, XY values in a separate table. And similarly, we can also focus on some tables inside the document that we can see on the right, and extract from the table the values of the header inside the table. If needed, the user can also edit the values if it's not correct because of some error, for example, in the extraction. And these 2 tools can absolutely support the user to recover all the historical data set that we have usually in the company in form of PDF, in papers, in order to be able also to reconstruct, for example, the history of one specific asset and so on, and integrate all the quantitative information in new modern analysis. Now I'll leave again the floor to Hussein in order to see a little bit better which architecture is behind all these systems, please.
All right, thank you so much, Francisca. So we wanted to give you just kind of a start with the high-level block diagram of the different entities or different system modules within what you saw so far. And so if you want to start with at the front end, you've seen a UI that's designed specifically for a natural language processing type of interrogation, supported by a context definition. And so in order for us to provide context to that search, We leverage Amazon TextRact to extract the text as well as the tables. So there was very specific training to recognize the table structures in those documents. But we're also using Amazon Comprehend to identify the business entities needed, like well names and basins and other entities, to enrich and provide a more context-based answers. Additionally, for the image classification, we're using recognition and a very specific custom-made image classifier through Amazon Recognition Service that allows users to search based on images, based on titles, based on things associated with that particular image. And what I want to say it's essential to note is that we're trying to build this on a serverless architecture that allows the scalability and the security of ingesting and feeding into it, hundreds of thousands and millions of documents at the end of the day, and pulling data from proprietary systems as well, or systems of record beyond unstructured data. To go a little bit into the specifics in the architecture design, we're, and this is really encompassing both front-end and back-end capabilities. And building on the services that I mentioned, like TextRact, Comprehend, Recognition, I do want to highlight Kendra, which was very essential in enriching the summaries and the more natural language interrogation of the process. And so what we're doing is we're leveraging Kendra as a natural language processing engine, and we're also incorporating an open source large language model with Llama 2 to enhance the summary and the demonstration that Francesca showed on each one of the search results. And also, as you can imagine, you can see the kind of usual suspects of API gateways to handle API calls and management. SageMaker Jumpstart is used to enable the integration with the Llama model, and further and further. Now, sorry, did not realize these were supposed to be. So again, TextRact, Comprehend, Recognition, each was building for a specific purpose, and then really integrating the generative AI extension to existing services. And this was all done, again, this is early stage in the project, prior to Bedrock and what you heard today or this week with Amazon Q, which would replace some of that, right? And so we're leveraging, in particularly with Kendra and the language model, is the retrieval augmented generation or RAG architecture to combine the two and create that synergy between them. And now we can start exploring Q and some of the other services to make it a little bit easier, less custom built. But our job doesn't stop here. This is really the beginning of the partnership and the relationship and this collaboration. Our aspirations is to start integrating this with third-party applications from a data source and potentially from a workflow standpoint. We also want to start incorporating, like I said, some of the more managed services, generative AI services, like Bedrock and Q, et cetera. We're also wanting to incorporate and make GECO potentially more of a canvas for collaboration than just a search engine as it is today. That's the first step, and then we take it further. So pulling into kind of creating it as a canvas of collaboration that pulls different data and rates data based on experience of previous geoscientists and users, and create a collaborative space that pulls that data becomes the driven part of it. And lastly, which is really, really important, is the integration with open standards and industry standards like Open Subsurface Data Universe, very specific oil and gas standard for those who don't know, because we want to ensure the interoperability and adherence to industry frameworks and best practices and APIs to enable that interoperability that I talked about with the third-party applications. So I want to hand back the mic to Francesca to go over what we're doing next and some of the key benefits for GECO.
Thank you, Sam. So, last two slides. Just to conclude, which are the key benefits that we foreseen in this tool, in the use of this tool. First of all, the use of the collaborative ecosystem, in our opinion, will improve our de-risking capabilities and process, since better quality, accuracy, completeness, and correctness of all the information through an integrated multi-scale management data and workflows could improve the quality of our geo-model and our results, our activities and projects. And at the same time, we can minimize the cognitive bias of the user that we have seen and sometimes could occur and leads to the same way of working and obtaining results. Second, we improve our efficiency, since the optimization of the search times and the information evaluation with the support of Gen AI technologies, it will be a pragmatic and effective improvement of our efficiency of working, saving time. And third, thanks to the transversality of the system, as we have seen, it will be applicable and usable to the different business line within the companies, starting from the more conventional and traditional oil and gas to the carbon capture storage, for example, or the development of the renewable energies. But also outside the industries, as we have said, with a foreseen potential adoption outside within international and organizations and institutions. And as a last point, as we have seen, we are often requested to accelerate the deployment and development of our discoveries and the project. And this request the full data consistency of our data in order to guarantee the high quality and also the right use of the data within the long process that could be also iterative with different resolution between the different technical functions that are working on the same asset. So what's next? As Hussein already said, we are just at the beginning of the journey. So GECO is we are developing GECO, and the ecosystem is rapidly growing, expanding the technical capabilities and progressively including different types of data. We will add, of course, structured data following the finalization of the unstructured data. We will improve our capability of analysis. And we will also, we have already included in the system the tool to visualize what is the virtual outcrop model, that is an acquisition, a digital acquisition of the rocks on the surface, the outcrops. And we will improve also a tool in order to extract and quantify all the measurement on the virtual outcrop in order to de-risk and better constrain our geo-modeling in the subsurface. Again, we will include the cores, the laboratory results in order to expand also the range from the outcrop to the microscope data and expand also the data providers of the structural and structural data, and finally with the wells. At the end of the day, all the phases and package will contribute to an effective ecosystem of insights, heterogeneous populated, and to propose an unbiased space to create our futures. So this is the end of our talk and presentations. Thank you so much for the attention, even it is late in the evening. And if you have any question, please feel free to ask.
Yeah, thank you.